Thanks for, first of all, I wanted to say welcome, everyone. It looks like we have a great group of people here today. I know a lot of sessions, Java 1 today and tomorrow, all the week, and a lot of them are really interesting. And I really like to thank you guys for taking your time and coming here today. Not a small thank you, but big thank you to everyone. Whew. Thanks for being here. So first of all, I wanted to kind of introduce myself. I'm from Voronezh, Russia, and this is what it looks like. It's a very beautiful city. I don't know if anyone been to Russia here. All right, we got a few people. Very cool. So are you guys from Russia, or are you just visited from Russia? Okay, perfect, cool. So people also ask where it is, because Voronezh, Russia. I mean, it's a Russian name, so here's what it is on the map. Okay, Moscow is right there, about 300 miles south, about an hour flight. It's very heartlandish, so it's basically kind of like a Midwest over here in America. So a lot of agriculture, and it's very Russian. So I work for Capgemini. I'm a consultant, senior consultant. I work in custom development. I specialize in Java and J2E technologies, and I work for Capgemini for about seven years, over 7 years now. So I know I probably have a lot similar background. There's a lot of people over here as well, and so I think we'll find a common language. But the interesting thing is, right now I'm not I'm not a custom developer. I'm not like a developer role currently. I'm actually doing the application management and support. This is kind of a core idea I wanted to bring today, kind of a fusion of the application development with application management and support, where the boundary is. But I will talk about it a little later, and you'll get where I'm coming from. So my colleague over here is Shalindra Swain. So
thanks for coming. I am Shalindra Kumar Swain. I am from a place called Odisha. It's in India, full of temples. And you can know, I don't have to introduce myself, you can know it from my accent.
Yep.
This is where it is located, on the east coast of the India. I have got 10 years of custom development experience, mostly using J2E technologies. So my colleague will explain what this topic is all about. And then we have last 2 slides, we'll compare like what is the difference we get if you go for custom build over buying a off-the-shelf product. And will not take much of your time. You are already tired.
All right. So here's a big question, right? I mean, why are we here? Like, why is this topic important? Why is it worthwhile to talk about it? So I wanted to kind of make this session a little bit more interactive. I know a lot of people use a lot of bullet points or whatever. So, but I wanted to bring you guys as part of the discussion. And can someone here kind of give me an idea of why it matters, why you guys are here? If you guys can raise your hand and kind of give me. You're curious yourself, so you okay? Uh-huh. Okay, fair enough. Okay, so okay, it could be pretty straightforward, right? But okay, that's a good question. Okay, anyone else?
So we kind of are in a distributed environment today, completely diversified in all kind of different platforms.
Okay.
I'm kind of curious to know, like, how the messaging happens, notification happens from different systems to different systems in different platforms.
Okay. So, okay, the distributed environment and how the notification happens in distributed. Anyone else? Yeah, please.
We're planning to implement a lot of messaging systems, so
Okay.
curious about this.
A lot of messaging between systems. Okay, to implement. Okay, please.
I'm curious how we can push messages from the systems.
Okay. How to do it? Could you speak up? Actually,
How would you scale a messaging solution?
Mhm.
Usually, the order is more complicated.
Okay.
If you scale it, you have less to do with the order events.
Mm-hmm.
Is there a way to work around?
Okay. Good question. The
The
specifics.
question is about like, let's say you have a system where you are doing for ordering system, right? You book order, then you can modify, you can cancel, right? If you do a multi-threading in that case, let's say you put messages in the queue or topic, right? If you do multi-threading, what will happen? You will end up consuming the modify message first, then book next, right? So how do you address all these issues?
Yep. Perfect. All right. So we'll. Those are all great ideas of why we're here, why we're talking about this. So first of all, I wanted to tie it in into being developer to being a part of application management, right? So as developers, a lot of times we think, here's our world, right? I mean, there's a design, develop, test, and launch, right? There could be other things happen. You know, could be business requirements gathering, and there's application support. So there's business requirements on the left side and application support on the right. But a lot of times with developers, we kind of we just want to build, right? We want to introduce new functionality, and a lot of times we under the time pressure to build it as quickly as possible, right? And this is where I was maybe until about 2 years ago. So I was really focused on very concentrated delivery and building features, building the functionality. So now, but when you launch, right? Like what happens, right? You launch something, and then magically it's gonna be live, I guess. I don't know. Some people are gonna use it. But the question is, it's not just about the users, right? It's also about how easy it is to maintain the application, right? Because there's going to be, first of all, the availability of the application is crucial, right? Majority of the companies, right, they want the 24/7 availability of their systems, right? So we can't really just expect it to randomly go down, but we have to also take into consideration that there are people who actually make sure that the system is up and running, those 24/7, right? So the people have to constantly babysit it and constantly have to make sure that there are no problems in the system. So what happens a lot of times, we introduce. It's not a monolithic system, an enterprise system, right? There are a lot of components. So it's not just one application. There are multiple applications involved in the regular, in the business transaction, right? So as we introduce more and more application, as you see in this slide, the complexity of the system grows. The more and more interfaces there are, the higher and higher probability that something will, not work as it's supposed to. Something will go down. So what will happen in the case of synchronous load? So, the easiest way would be, you know what? We'll just make sure everything is real time, make everything happens at the same time, and that's the first urge, right? But the question is it a right solution? And as you can see here, if one of the system will go down, it will significantly affect everything, right? If everything is real time and one of the components is down, then the whole flow fails. So there are significant problems with real time. As I said, first of all, real time calls to external systems slow. They could be very slow because sometimes it could be a new system, sometimes it could be a legacy system, right? And the older the system, the more complex it is, the higher chance that the calls will be not performant. Then there's also a high probability that any of the system will go down. It's just a given that something will go wrong. So what will happen in this case, right? If something goes down, somebody will get a call at 4 o'clock in the morning to try and take a look at it, right? So that's not me in the picture, but I've been in that situation quite a few times. So here I am. So anything that can go wrong will go wrong, right? You've all probably seen this, but the cool thing is, I love this, is that Murphy was an optimist, right? Because he given us the word of warning, right? I mean, we have to prepare for the worst. So that's why I feel like the second quote is very actual here. So now, of course, we, instead of debugging problems, connectivity interface issues at 4 a.m., we'd rather all be at the beach. So what can really be done, right? I mean, we really have to think strategically and look at the enterprise system holistically, right? And look at all the different parts that are involved in the business transactions.
This is basically what we face every day in, day out as a developer. So this is basically to get you a feel like what we are experiencing throughout.
So first of all, what can we really do? Obviously, we need to simplify. When we look at it, we need to figure out what part of the business process can happen later. We can club everything in one place. We need to really divide and conquer and only have the crucial transaction happen real time, and then everything else should be offloaded to later. The good news is that a lot of times the synchronous processes, in the larger business flows, there are parts that are synchronous, and there are already parts that could be naturally be made asynchronous, right? So think about getting a coffee at Starbucks, right? What do you do, right? You walk up to the cashier, you pay for it, and they write down your drink that you want to get, right? And then send it over to barista, right? So the transaction is done, and barista then tries to manage the load, and maybe some drink may take faster or slower, right? But it's up to the barista to do it. So what are the different integration approaches in this case? So if you want to really offload things to later, right? What are the different ways we can go? So some of those could be a batch process, right? Or batch and a file transfer to an external system. So we integrate the system by downloading data to it a little bit later, right? Not real time, but down in the future, say nightly or hourly or however it may be. The second will be shared database, right? So there could be data in a database. There could be different people accessing the same data. Or there could be some kind of a synchronization process that runs in between the database schemas, right, that syncs up the information between the two. But what really we want to talk about today is the messaging, right? Out of these three, there's definitely advantage and disadvantage of each, but I think messaging is generally accepted as to be one of the newer ways to integrate systems. So it is really the topic of discussion today, so I'll concentrate on this. So now we saw the synchronous flow, right? We saw what happens if everything is in one transaction. Now, if we simplify the process and take the systems out of the main business transaction, main business flow, and put some kind of a messaging component in between, you can see how it actually simplifies, how it makes it more reliable, right? So same exact picture as before, but you can see there's a topic in the middle, right? What happens? So main transaction just pushes a message, right? And it forgets. So it continues doing whatever it's been doing. It published, it finished the business flow, and boom. Now, all those external systems, they are there, and they need to subscribe, right, to the topic, the register, to be able to consume those messages. So really, each external system goes and subscribes and registers to receive the event. Now, if one of the external systems is down, as we saw, I mean, it's a given, right? It's not a big deal because the main transaction flow will still be there. I mean, it's going to be working as it was, and all the other external systems will still be functional and getting the updates. But the external system, once it goes down, if it comes back up in a few hours, it's not a big deal. It will still get the messages. So compare the synchronous with asynchronous flow. So now, we talked about this simplifying and looking at how the business transactions could be simplified and split up into the synchronous and asynchronous components. So what we really, once we've done that, once we've gone through that process, we want to also look at the technical requirements. Okay, we know that we need to split it up, right? Like how we do it, like what should we be looking for, right? And also we also want to look at the business practices, the best practices that are out there available for us as developers or as software architects or enterprise architects. So for example, this is one of the technical requirements that we've talked about. So we don't want to impact any other flows if system goes down. So second one is guaranteed delivery. Those are different examples. I mean, this is not the complete list, but to give an idea. What is guaranteed delivery, right? If something is down, we don't want to miss a beat, right? If something happened while the system is down, we still want for it to receive the notification, right, and update a message. So that can happen. That actually, there could be two parts of that guaranteed delivery. Sometimes the legacy systems can completely go wrong, right? The database could go corrupt, and there could be significant problems. So guaranteed delivery may not even be purely to say that the messages will still be there in the messaging system, but there may be also a requirement to provide some kind of a reload mechanism where all the messages that it missed, even if it got the messages at the end, it will still want to receive those one more time. So then another requirement is support a multi-threaded processing. So we do want the system to be as quick as possible, even if it's asynchronous, right? So we can't wait for a message to be there in the queue for hours or for days, right? We want for it to be processed as quickly as possible. So we need to be able to introduce multiple threads reading off of the same queue of the same topic to be able to process those as first come in the queue as quickly as we can. But the interesting thing is that once we introduce a synchronization or multi-threading, right? There always the light bulb goes off, right? Okay, what about the synchronization, right? I've been actually to a couple sessions today about the multi-threading, and they talked about all the race conditions and the dining philosopher's problem, and it was pretty good. And so we need to find a way to synchronize. If we have multiple threads reading off the same queue, we need to be able to find a way to synchronize them. Because if something, say, if order is placed, right, and order is placed and suddenly you change your mind, right, you want to cancel it, right? You can't have a cancel be processed before the actual order is placed, right? So those kind of things. And if there are multiple threads reading off the queue, there's a good chance that one could be processed before the other, right? So you need to be able to synchronize it somehow. Another point, systems, especially legacy ones, they don't natively support say MQ integration, right? A lot of them may be TCP/IP interface, or they could be web service based, right? So you can just plug and play. You can you can add an external system and expect it to integrate immediately. So you need to have an ability to have an adapter, to be able to build an adapter to integrate the external system into the whole messaging flow. So need for adapters. And the last but not least, we all know that the systems usually change. They're never stationary. So there's always something in flux, and there's a very high chance that their new system need to be introduced. So the system needs to be, the technical requirement in this case would be the flexibility of introduction of additional external systems over time, right? We need to be flexible enough to do that. So now, so those are some of the technical requirements. Okay, what are the best practices also? There are quite a lot of good books out there, and obviously everybody's seen the Gang of Four patterns, right? But one excellent book I found was called Enterprise Integration Patterns, and actually a lot of it is, a lot of the patterns that are described in that book are based on the Gang of Four patterns. And it's a very phenomenal book as to, it explains really from the grounds up, what are the messages and all the guaranteed delivery, and how you build the message and message channels together, right? How do you start with the smallest components and then build on them to create a bigger system. So I wanted to kind of give an idea of what is in that book, so and also kind of bring the topic that we talked about today with the patterns that I described in the book. So one very interesting one is the notification of the external system. Okay, how is it done? A lot of times notification happens using the event messaging mechanism. So in this case, the systems register, and when event, the main application triggers the event, and then only the systems that really registered for the event will receive the message. So then, building on that, we need to be able to integrate the system which doesn't support the messaging out of the box with the messaging system. So how do we do that? We add the channel adapter, which then sits in front of the actual system and talks to it, and at the same time it provides the nitty-gritty detail of integration to the messaging system, to the MQ. So in this case, you can see some of the systems may actually already be able to integrate out of the box, while others need the channel adapters, which are sitting in front of them. So again, the adapter is really just the pattern builds on top of the Gang of Four channel adapter pattern. Then another really interesting one, which I would say very useful, is the message router, right? So we adding the complexity, right? So we had the observer systems which are listening for the events. Then we added the channel adapters in front of them. And then we added the additional third component in the middle, which is a message router, right? Because not all the systems may want to know about something, right? We only want to send the events to certain systems which really need to know. So it's kind of on a need-to-know basis, right? So how do we do that? We need to introduce this middle component called message router, and that component actually looks at the message. It doesn't do anything with it. It just forwards it to the appropriate system. I
would like to add a few points there. The router that we are talking about, it has some intelligence. The intelligence is basically, you can call it content-based routing. It will probe the message. It will see what kind of message it is getting. And you can have some configuration or database configuration there. Router can go to database and find out who is the intended recipients for that message. So that routing logic should be inbuilt in in the router.
In the message router. So in this case, any of the observer systems or subscribers, they don't really have any knowledge, right? They just care whatever comes to us, we're going to process. The message router just looks at, say, XPath if it's an XML event, right? It could look at some XPath, some content of the message, and then figure out where it needs to go, right? And obviously internally, it may have some database configuration and something that will tell her how to route the messages correctly. And then finally, we talked about the smaller subset, and there's also kind of like a bigger picture pattern that's called the message bus, and some of the ESB, enterprise service bus products out there in the market that actually implement this pattern. It's just the way to integrate all the applications, have a flexibility of adding and messaging between different applications without them really knowing about each other. Okay, so now we talked about the requirements, the best practices. Now, once we've defined those, we have all the knowledge, right, to help us decide what to do at the end, right? We need to figure out what to do, either do the custom build or select the tools. So Shalindra will actually walk us through the this section.
Yeah, this is basically a brief comparison between custom solution and the products that are available out there in the market. You can call enterprise service bus or web service family of specifications like web service notification, web service reliable messaging, security, all those things. Why we are talking about all these things? We can go out and choose a product, and we just need to know how to use that product. Why we are talking about all these design pattern and all? So basically, there are a few points. This is just a honest comparison that we get from, you can go online and find that out. So initial cost. So when you go for custom solution, the initial cost will be higher compared to the vendor product. Initial cost is higher, but if you consider the maintenance cost over a period of time, but here the custom solution is going to win. Every time you get an upgrade or you move to if you need a high availability solution, you need to duplicate your deployment, right? If you go for a USB solution, then the deployment needs to be duplicated across multiple machines. So in that case, you need to buy a license for deploying the application on other boxes. Documentation. Generally, here what we are trying to point out is not all custom solutions are poorly documented, but it is just overlooked. So the developer writes code, maybe he knows that the code is readable, so no need to put any comments or things like that, correct? And for marketing purpose, vendor don't have any option. They have to go for a better documentation, otherwise nobody will buy it. It is going to be a black box for the users. Skill set available. If you go for a custom solution, you don't have any skill set. What you need to do is you need to train your developer. You need to come up with the design and the solution detail. Then you need to train your developer to come up to that level so that they will be able to contribute to development and testing of the product. For vendor solution, there are already skilled developers available in the market. You can go hire them, choose a product. For that, you need to do lots of groundwork. Like there are tons of products available, ESB product, open source product. So you need to do some initial analysis. Again, you will be investing something in that. Then choose the better product and hire the developers and implement the solution. Flexibility, custom solution. We know what we are building. It is very easy for us to modify our own code rather than modifying somebody else's code, right? Vendor lock-in. Sometimes what happens, if you buy somebody else's product, then they will say, okay, you need to use our hardware, because the way the product is built is basically it will perform better than if you use our hardware. If you use somebody else's third-party hardware, it will not perform up to that level. So that's vendor lock-in. The other thing is you don't have a choice to duplicate. As I said, if you want a high availability solution, in that case, you don't have a choice but again, you need to pay for the license. Single point of failure. Custom solution. It's again similar to high availability, right? If you can have active solution or active passive solution. So that's up to you how you implement how system is designed to work. Like we discussed in the previous slide, you have a queue. Let's say you have a queue, you are going to duplicate your deployment, right? You'll have two applications consuming messages from queue, right? Two applications, I mean the duplicate of, we are duplicating the application, right? You will end up consuming same message from the queue 2 times, correct? So you don't have a choice there. You cannot go for duplicating the deployment in case of vendor product. But if you go for some custom solution that we have already implemented for some of our customers, you can go for that solution, synchronization, all those things you can build. Java is focusing very much on that area, like we got multi-threading in Java 5, then again Java 6, that they are reviewing that API to have a better solution for multi-threading. Again, multi-threaded processing. Multi-threaded processing, basically, if it is custom solution, you can figure out the areas where you can implement parallel processing. Since it is your own code, you know how to implement multi-threading in there. If it is vendor solution, then you have to reach out to the vendor to figure out the different areas where you can multi-thread the business logic, or it can be interaction with any other external systems. Legacy system adapters. Custom solution is basically a adjustable range. It can be used for any sizes of nut and bolts. And the vendor gives you some facility, especially when you are dealing with lots of legacy systems. So vendor might not have a solution for that. You have to go ahead and build it for yourself. Changing business needs. We are all experiencing all these problems day in and day out. Every day we get some requirement, like business user will say, I want this requirement in this week. I want this requirement ASAP. So if it is a vendor solution, then you need to do lots of groundworks. You have to figure out how to implement that particular requirement. If it is a custom solution, in that case, you know what you have written there, how you have designed your system. So you can engage a couple of developers, designers, then you can get it done in like few weeks or a few days. Impact on the system down. That's again what we explain, asynchronous messaging, all those things we can implement in custom solution, which is like may or may not be supported by the vendor solution. So this is all about comparison. If you guys have any questions, you can.
Yep, we can. So move on to the next slide. Yeah. So we wanted to open it up for discussion to make it a little bit more interactive. Okay.
So essentially, if I understand correctly, you're suggesting that we should use custom solutions here, or?
Right. Today, let's say you have a small business, right? Why will go out and buy the ESB product? There are lots of open source ESB, lots of framework, you name it and you have it. Let's say ESB product like I can talk about Fuse ESB. Then from Apache we have Fuse ESB is from Apache. There are other solutions, ActiveMQ from Apache also, that can be used for developing your own ESB.
And how would you really compare? So ActiveMQ is just a broker solution, whereas Fuse ESB would be an enterprise service bus.
There is Apache service mix also. That's exactly does what ESB does today. So any vendor solution.
How would you really differentiate between ESB and broker kind of solution?
It's actually cost and maintenance. So if you go for vendor solution, over a period of time, if you compare the cost, you will be spending more.
No, that's okay. I'm trying to understand.
Well, I think you have to consider the requirements that you have, and maybe the ESB may be overkill, right? It may be easier to just use ActiveMQ or whatever, right?
Yes, I actually don't know how the ESB implementation is done, so I'm just trying to understand that.
Right.
How is it different?
I think ESB is it builds on top of the MQ, right? So it's a lot more. It's a higher level of abstraction, right? There could be a lot more functionality in the ESB product versus just a pure ActiveMQ, right? So as I showed in some of the slides, right? I tried to take the smaller, like the simplest pattern, right, and kind of build on it, right? You add the adapters, you add the messaging router, then you take that and or you can have an ESB, which is totally, you know, high level, very high abstract system that, you know, just integrates the two different, you know, applications without even them knowing about each other.
So especially you should not go for ESB whenever you have a small enterprise, you are doing like small business. ESB is pretty costly nowadays. Any ESB solution. We don't have to name the vendor, but you can go out and find it out yourself.
Yep. Anybody else? I think we had some questions earlier about something about implementing some solution down in the future pretty shortly. No.
If you have specific problem you want to talk about, then we can discuss that here.
Yeah. So definitely, yeah. So yeah, feel free to stop by and do one-on-one or just more on to the next slide. So we have our, you know, beer. It's 5 o'clock finally. So we're probably gonna go down to the bar at the Hilton. What's it called? I need to figure it out. The Urban Tavern. If you guys want to join and talk over beer, I mean, you're welcome to.
Cool. Thank you.
Okay.
Yeah.
Thanks everybody.
All right. Thanks a lot.